This week on The Futurists, Marc Theermann.
We've proven that we can build robots that can go anywhere that a human can go. Now we're really about figuring out how to manipulate the world around us.
Well, welcome back to The Futurists. I'm Rob Tercek with my friend Brett King joining us in the co-host chair. Hi, Brett. Good morning or good evening, wherever you are.
Yeah. How you doing?
I just watched the sunrise, so we're having a very early California morning here.
Yeah. Well, that's early. Yeah. Oh, it's nighttime here in Thailand. So
the past 2 years have really been the 2 years of artificial intelligence. The term keeps coming up, no matter how much we try to focus on other topics on this show. It just seems to be inescapable, and everyone wants to talk about it. But there's a related topic to artificial intelligence, and it's one that I've always been quite fascinated by. I think a lot of people are, because we've seen videos on YouTube of robots that can move autonomously. And so robotics and AI are two intertwined concepts in computer science and in industry. And one of the companies that has made those incredible videos of the robots that they've built is Boston Dynamics. So we're really thrilled to have Marc Theermann join us. Marc is the Chief Strategy Officer of Boston Dynamics. Hey, Marc, welcome to the Futurists.
Welcome. Yeah, Happy New Year. I'm excited to be here.
Thanks to
I got a bit of trivia for you, Marc. I don't know whether you know this, but do you know where the word robot was first used in popular media?
I do, in a very old play. And it stems from the word roboto.
Exactly. A Czech word, roboti, which is in the plays was depicted as a mechanical serf, like a servant. And it stuck. The Czech word for roboti became robot in English, and we use it today. So that was from Rossum's Universal Robots in 1922, correct.
For those who are listening, let's talk a little bit about Boston Dynamics, because I think the name of the firm might not be familiar to everybody who's listening. Of course, it's familiar to those YouTube geeks that love to watch videos of robots running around and robots getting kicked in parking lots and all the other strange things that we've seen over the years. So Marc, tell us a little bit about Boston Dynamics, the company, how it was started, and what you focused on.
Sure. We are a 30-year-old company that's located in the suburbs of Boston. And we build mobile autonomous robots. So while there's a long history of stationary robots, Boston Dynamics really focuses on mobile robots. And today we have 3 robots. We have Spot, which is a 4-legged robot that looks a little bit like a dog. It is yellow, and you have probably seen YouTube videos of it. We have a 2-legged robot called Atlas, which is called a humanoid, because it looks a little bit like a human. And then we have a 3rd robot, which is called Stretch, because it stretches deep into a container to unload flow-loaded containers and unload parcels in logistics.
Oh, so in the past, I've seen videos of things like Cheetah, which is the fastest robot ever built, right? It's a robot that's faster than Usain Bolt for Olympics geeks. Are you no longer making it, or is that just an experimental project?
Yeah, that was sort of Spot's grandfather, if you want. So we've done lots of robots over our 30-year history, but the 3 robots that we're currently commercializing are those 3 robots, and all the other robots are their grandparents, if you want.
I see. Oh, so there's generations of robots. I'm sure people who have looked at the videos have seen the classic videos of Big Dog.
Yeah,
that super noisy and incredibly freaky thing that can carry 300 pounds of gear over the mountain, and it sort of walks like a dog, and it just sort of doesn't look like a dog. It's headless. If you haven't seen the videos on YouTube that I'm referring to, you'll smile when you watch them, because they're uncanny. I think that's part of the key thing. Robots, because we conceive of them, we design them, we typically think of them as kind of an extension of humans, maybe even a mirror of people or animals that are familiar. That's why the names of your creatures often have, they resemble an animal. Or Atlas, looks uncannily like a human when it's dressed up in.
When it's in motion as well,
and it can
very
jump
human-like movements. It's interesting, actually. I've got a theory on this, that if you look at a lot of science fiction, we've depicted robots in humanoid form. Now, we did that because robot actors could act in suits that look like robots. But Mark, from your point of view, we also see, Tesla working on a humanoid form at the moment and so forth. I've done some work with Beyond Imagination with a Beyomni robot. Humanoid form factors are something that we've often aspired for in our robots, but because, it's familiar. And, you want to be able to have these robots work in situations that humans would. But in terms of pure design, is the human form an efficient form of robot design, or is that just more because of sort of the popular demand that makes robot humanoids more sort of world accessible?
I think that's a key question, Brad. So on the one hand, yes, I think there is just general pull that we strive for that form factor, right? From C3PO onwards, people want to interact with robots that look like humans. But there's actually very practical reasons to go for that form factor. If you have wheels, you are sort of excluded from a large portion of a factory floor because there's pipes on the ground, there's steps to go to the next level, there's thresholds that you need to step over. So wheels, while they're probably more efficient, exclude you from many areas in a factory. So legs are good. And then two arms are good because this world is built around the human form factor. And Boston Dynamics robots are really geared to be put into situations without bolting anything new to the ground. You can automate a lot of things in a factory by putting fixed automation in. Our robots are meant to be put in without bolting anything new to the ground. And their two arms come in very handy because much of the workflow that is designed in factory is designed around the human form factor.
Right.
Pretty important.
So there are some practicalities to it. Yeah.
So there are some other robotic companies. Robots have been in factories for 30 years, particularly in the auto industry, where most of the body plant today is automated in most auto factories, perhaps all of them. Those robots are deaf, dumb, and blind. They cannot see people. And for that reason, they're usually enclosed in cages, sometimes with fences around them to keep the human workers out. And in fact, human workers in auto factories have been killed by robots in Japan and the US and Europe. So they can be quite dangerous. Those machines, they're moving very fast. They're very powerful.
I mean, people get killed by trucks in loading bays and stuff as well. So
sure, but that's not the point I'm trying to make. What I'm talking about is that that has been the case now for 30 years in auto factories, and auto companies now have gone entirely robotic, but they're using fixed robots to do that, and they're using a type of robot that can't really see or detect the world around it. So it knows where it is. It knows what it's meant to do. But it doesn't have to be a very sophisticated robot relative to the kinds of robots that Boston Dynamics makes. If you're going to ask a robot to walk or go upstairs or pick up a box or select a box from several and find the right box and carry it up upstairs, that robot has to think on some level. So talk to us a little bit about the interplay between artificial intelligence and the types of artificial intelligence that robots use.
Yeah, Rob, there's a bunch of questions in there, but you're absolutely right. The difference between our robots and a fixed stationary robot in a manufacturing plant is at the highest level two different things. Number one is our robot has to understand its environment enough to walk around in it and not bump into things, either humans, walls, garbage cans, what have you. So there's a level of autonomy that our robots have that is important to get that mobility. So our robots do use artificial intelligence and machine learning and lots of cameras to understand their environment, create a digital twin for themselves of that environment, and then they're able to function in this environment autonomously. The second one is that a classic automation robot can only do one task very specifically, and it picks up a widget and places a widget somewhere else. If you move that widget by 3 centimeters, the robot will not find the widget anymore. So these new class of mobile robots need to also have a semantic understanding of their environment and learn how to navigate in unstructured environments. For our robots, if you move the widget 10 centimeters to the right, the robot will still find it and still be able to move it. So you have sort of, on the one hand, the autonomy, and on the other hand, the semantic understanding of the world that gives a much higher level of flexibility than fixed automation ever had.
So that's a considerably more difficult problem to solve. Actually, it's probably a collection of interlocking problems. Can you talk to us a little bit about the difficult problems that have already been solved in robotics, and then tell us a little bit about what remains, what problems have not yet been addressed?
So I think we're pretty close to having solved locomotion at a very high level, because you've seen our videos. So over the last 30 years, we've really worked on locomotion and being able to walk anywhere that a human can do. And so with our four-legged robot, we can go up and down stairs, we can go over obstacles, we can go in grass, in sand, in gravel. So without much difficulty, our robots can navigate all kinds of environments. And much of that has to do with control software. And there's now a revolution going on where you teach these robots with reinforcement learning to navigate even more crazy environments that they have not encountered before. Because, of course, in a controlled software environment, you teach the robot something and you anticipate the environment. In a reinforcement learning environment, the robot might be able to walk on ice all of a sudden, which it couldn't do before. So I think that's a very solved portion of the equation, I would say.
Is there what remains to be solved? What challenges lie ahead?
So today our robots have a minimal semantic understanding of their environment. So our robot, you teach a robot a route through your factory, and from that moment on, the robot can autonomously execute that route, even if the route changes. So for example, there's a forklift in the way that wasn't there yesterday. The robot will recognize that and walk around it. There's a human in the way. The robot will recognize that and navigate around it. But the robot doesn't understand what it sees. It sees the world as obstacles that it navigates around, but we're just at the cusp of the robot actually understanding, I'm looking at a forklift, I'm looking at a human, and I should react differently to the forklift than to the human.
And the type of artificial intelligence that's required here, well, the first one, of course, is machine learning. But you're also talking about semantic understanding. So the ability for the robot to develop its own internal model of the world and start to make associations. Can the robots actually reason yet? Or does that lie out in the future where they can start to make, their own independent decisions?
Well, I think we work feverishly on something that internally we call object detection, so that the robot recognizes a specific object, and then it can reason, how should I handle this particular object? And right now we're doing that one object at a time. So you teach the robot an object and say, this is a coffee cup. The robot runs through thousands of simulations how to handle a coffee cup. And then at the end it says, okay, now every time I encounter this object in the real world, I know how to handle it. So there's some amount of reasoning, but it's sort of one by one, Rob, right?
So like if you show a robot a coffee cup like this, to use your example, can it then intuit or figure out that this is also the coffee cup when you spin it around? And for the people who are listening, I'm just showing a coffee cup and I'm showing the handle on either side.
Yeah, that's what the simulation environment does. So that the robot can handle the object in any orientation and know how to manipulate the object in any orientation.
So you're actually teaching these robots to have this level of adaptation in a virtual simulation rather than having to train them with cameras in real world situations all the time, right?
Yeah, I think there's a couple of different ways to do it, Brad. We've put people into motion suits, from the movie industry. We have a human do the task and then the robot can imitate it. There's companies working on teach and learn. The robot watches you do a task, then the robot tries to do it. But all that requires then simulation to follow on so that the robot does it, 50,000 times. But, there's different ways of input methods. Another one is, of course, virtual reality or augmented reality goggles. Right. So teaching the robot the initial task, then simulation, then putting that onto the hardware and having the robot perform that in real life. And then, of course, ideally having to do that reliably in a Hyundai plant is where we want to get to.
And you mentioned Hyundai because Hyundai is actually the new owner of Boston Dynamics for the past couple of years. Previously, Boston Dynamics, as you mentioned, has been founded 30 years ago as a spin-out from MIT. It was previously it was acquired by Google. And then I think Google sold an interest to SoftBank, who in turn sold it on to Hyundai. So is factory automation a primary focus for you, or are there other areas that Boston Dynamics is focused on?
So Hyundai owns 80% of the company and SoftBank owns 20% of the company. Hyundai is an amazing parent for us because our ambition is to really build tens of thousands of these robots in the coming years. And so Hyundai is, of course, known throughout the world for building high quality, affordable vehicles. And we want to do the same here. So they're an amazing parent. And yeah, factory automation is a big part of what we do. But of course, logistics is a huge part for our stretch robot. And the spot robot, we found product market fit in industrial inspection. So you teach the robot a route through your factory, and you say to the robot, hey, take a look at this gauge, or listen to this CO2 pipe, or take a thermal imaging picture of this piece of machinery, upload all that into the cloud. Then we put machine learning onto it and say, hey, wait a minute, that machine is 3 degrees too hot. That might break tomorrow. Or I think I hear a CO2 leak in that pipe. So we have sort of 3 areas for the company by product, and factory automation is probably the biggest area for the humanoid robot.
It's interesting that Hyundai is the owner. It seems to me that the auto companies are beginning to realize that robotics is a big part of their future, not just in the factory where they've been using them for many years in the body plant, but the idea that autonomous vehicles effectively are another kind of
robots with seats in them, yeah,
that can navigate around. And then, we also, Tesla has made a lot of noise. Elon Musk has made a lot of noise about building his own biped robot, one that looks kind of similar, actually, in my view, to Atlas. So in some respects, you've got competition there, I guess, from Tesla.
Yeah, I think imitation is the sincerest form of flattery. And if somebody as brilliant as Elon Musk also decides that he needs to have a humanoid, I think we're quite flattered by him.
Well, I can see him using these in, on lunar missions and on Mars, in situ resource utilization and stuff like that. There's clear application for robots in the early stage of space colonization to be taking the risks that humans don't want to take in the early days. So, I think that aligns with his broader mission.
Sorry, robots belong into space for sure, right? Humans don't really belong into space, but humans also really don't belong into dangerous environments such as oil platforms, nuclear power plants, coal mines, right? These are all great places for robots.
Walmart. Sorry.
I was quite surprised when I was reading about your company to learn that the big dog robot, when it was used by the U.S. military, I think it was called LS-3. That version could actually march with 400 pounds of gear. It could go for 20 miles without a break. I was really stunned because that's a big machine, and for it to run on batteries
as well, right? Not. Yeah, I think they had the gas powered option as well, right? So.
Yeah, at the time, our robots were hydraulically actuated and gasoline powered. And yeah, we have that robot here in our museum. It is a big robot. It was purpose built
big dog
to test the limits of how much could you carry.
I see. Now, one of the things that robot shows, and again, you can see it on the videos on YouTube, is another area that's a big challenge is, I would say, like gyroscopics, or the ability for the robot to maintain an upright posture and continue forward motion in spite of obstacles or resistance. And one of the videos that's very famous is one where you've got one of the smaller robots, I guess it was an early version of Spot, in the parking lot and Boston Dynamics on ice. And one of the researchers is kicking it. It looks very cruel. It's like kicking a dog. So of course your heart goes out to the dog or to the robot. You feel sympathetic. And don't forget, those robots remember who kicked them, and they're going to remember when the robot uprising comes. They're going to remember the names
on
of the people who kicked
film,
them.
and the robot overlords come your way.
But the incredible thing is the robot can recover, right? After getting hit or after slipping on ice, it can recover and it finds its balance immediately, like within a second, and then it continues its forward motion, almost undeterred, right, by all that resistance. So that's probably another area, a big area of your R&D, because your robots do move autonomously. They've got to have some ability to keep on track, even if they run into something or get kicked.
Yeah, we try not to kick robots anymore over here, but you're right. But that's pretty much a figured out problem for us. Really, the next wave of research for us is around manipulation, right? We've proven that we can build robots that can go anywhere that a human can go. Now we're really about figuring out how to manipulate the world around us. And that requires A, a semantic understanding of the world, and B, the dexterity to be able to manipulate a variety of different objects. And that's really the core area of our research for the next 10 years.
Wow. Okay, that sounds quite good. Brett, how are we doing time-wise? Do we have time for another question, or should we break?
No, well, we got a couple of minutes before the break, so I think maybe let's just get into some more of the detail after the break. But Marc, I am interested in, in terms of sort of overall directionality. In 10, 20 years time, we anticipate there's going to be more robots on the planet than humans in a fairly short order. But is there a form factor that does give sort of broad advantages over human form factor?
Yeah, that's a good question. I wonder if robots will not become a little bit more specialized, right? You certainly don't need 2 legs for every application. 4 legs have allowed us to walk over a variety of different terrains. So 4 legs are a very stable form factor to go around. But I think as hardware becomes more affordable, as actuators become more affordable, sensors become more affordable, hardware is going to become in generally more accessible to a broader range of companies, which means that there will be entrepreneurial opportunities for startups to build purpose-built robots for very specific things. A tank cleaning robot, a lawn mowing robot, right?
Right.
So I think we won't see one form factor dominate. I bet we'll see a variety of
specialization.
Yeah.
Yeah, that makes sense.
A kind of Cambrian explosion of robot form factors is on the horizon. Okay, cool. Well, you're listening to The Futurists. I'm Rob Tercek with Brett King, my co-host. And this week, we're talking to Marc Theermann, who's the Chief Strategy Officer at Boston Dynamics. We're going to take a short break to hear from our sponsors, but please stay with us because in the second half, we're going to get really futuristic.
Provoke Media is proud to sponsor, produce, and support the Futurist podcast. Provoke.fm is a global podcast network and content creation company with the world's leading fintech podcast and radio show, Breaking Banks. And of course, its spin-off podcasts, Breaking Banks Europe, Breaking Banks Asia Pacific, and the FinTech 5. But we also produce the official Finovate podcast, Tech on Reg, Emerge Everywhere, the podcast of the Financial Health Network, and Next Gen Banker. For information about all our podcasts, go to provoke.fm or check out Breaking Banks, the world's #1 fintech podcast and radio show. Welcome back to The Futurists. We are with Marc Theermann, who is at Boston Dynamics. We've been talking about the range of different robots that they've been experimenting with over the last few years. But Marc, one of the things that we're seeing in terms of like this learning curve, where there's an intersection here, is also the evolution of these large language models or large learning models, if you want to make them more expansive, and that sort of ability to see trends that are occurring. And we are seeing application of this in fields like protein sequencing, in cancer diagnosis, and so forth. The ability for a robot to see these patterns in the world around them and to utilize that. So, how is the sensor and the image recognition stuff you talked about, how has the advancements in AI more recently helped you from a perspective of making robots more adaptable to their environment?
Yeah, that's a great question, Brett. So we did connect Spot, our 4-legged robot, to ChatGPT for fascinating results. So you can now converse with the robots and you can give them natural language commands and the robot will then do things. And it's a fun and fascinating way to interact with the robot. But of course, we're still at the very beginnings there because there's still a lot of hallucinations, meaning the ChatGPT makes things up, which might be fine in a word text. But if you're talking to a robot, that might lead to weird results. But we do have a ChatGPT powered Spot right now that gives museum tours in our headquarters here. But on a more serious level, I think that these large language models can be used to give the robot more of a semantic understanding of the world. So, for example, if the robot encounters a table, you could ask ChatGPT, should a robot stand on a table, right? And ChatGPT would know that no, it shouldn't. So that might give the robot more information. But we certainly seem to be at the cusp of a tremendous revolution in AI, and that will have a big impact on how our robots perceive the world around them and how we interact with them.
Certainly, the competition in the artificial intelligence space is going to influence robotics and the progress in that field. Another thing that advances progress in any kind of technology seems to be conflict. When it's about life and death, people get really serious about really innovating fast. And we've seen this in the past 2 years now with the conflict in Ukraine, and now suddenly around the world. The advances in drone aircraft are really quite extraordinary. It wasn't so long ago, maybe 15 years ago, that the United States had kind of supremacy with drone aircraft for the military in the Gulf conflict and the Afghanistan and so forth. But drones crash, they get shot down, parts get collected, other people disassemble them and start to learn, and suddenly, what do you know? There are drone aircraft now being built around the world. And this process has accelerated tremendously in the last 2 years. Now the conflict between Russia and the Ukraine, they say that conflict on the front line is buzzing with drones from both sides, that you're constantly under surveillance. And it's causing the militaries on both sides to reconsider very carefully how they move around things. It used to be a time was when a tank was the safest thing, the most difficult thing to kill on a battlefield. Now a tank is a sitting duck because a $1,000 drone can be in the air and can spot it and pinpoint it for artillery to hit. So suddenly that's changing the nature of conflict in tremendous ways very rapidly. Now, I don't know if they're using robots on the ground necessarily, but we have also heard about drone seacraft, underwater drones that are being used in that conflict as well. Can you talk a little bit about the interplay between the military in general and weaponization of robots? I know that that's not a field that you're currently in, but tell us a little bit about the interplay between warfare and robotics.
Where are
and
the lines being drawn right now in terms of autonomous battlefield robots?
Yeah, those are all good questions and difficult questions that we grapple with at Boston Dynamics all the time. My heart goes out to all the Ukrainians. It's a horrible time over there. And we've had interactions with the Halo Trust, which is the largest demining nonprofit in the world. They are currently active in the Ukraine. Sending a robot into a minefield is a very, very good application. Right? Because right now, that's either being done with sheep or shovels or metal detectors. But the next generation of mines are actually tiny fidget-looking plastic mines that cannot be detected by ground radar or anything. So sending robots into minefields is, for example, an amazing application for a robot. We at Boston Dynamics do work with militaries around the world on applications like that. However, we have drawn a clear line that we do not think robots like ours should be weaponized. And as a matter of fact, we signed a letter together with 5 other leading mobile robotics companies, including Anybotics, Agility, and ClearPath, to say, look, robots like these should not be weaponized. And so we think that there's amazing applications in the military, specifically around reconnaissance, demining, bomb disposal, but we don't think that robots like ours should be weaponized.
Yeah. Well, that's admirable that you guys have pushed that, because obviously, this is where the moral and ethical quandaries come in. And we've seen OpenAI has not necessarily dealt with that well. But that does bring us to this point of regulation in terms of what role does society have in defining the safe operation of robots? And it's difficult for us to assume that governments have the skills and knowledge to be able to put these right sort of ethical frameworks in place. But
for sure. So we actually have an internal ethics committee that discusses these things regularly. And we also have a government affairs committee that has recently worked with senators in Massachusetts to propose legislation against the weaponization of robots. And we certainly hope that that will become law in Massachusetts and then spread throughout the country.
Although I'm sure there's voices on the opposing side who say if we choose not to weaponize robots, we're just tying our hands behind our back. Well, someone else will do that. I mean, I think it seems like an inevitability that you're going to have a conflict that's robotic in the future. I recall clearly the first issue of Wired magazine in 1993, 30 years ago, had a feature story about the future of warfare. And at the time, it sounded like science fiction. I think it was written by Bruce Sterling. So, of course, it sounded like science fiction. And in that, he talked about cyber warfare, which clearly now has come to pass, right? When in some respects, we've been living through a cyber war for the last 10 years. And that seems to be intensifying with deep fakes, which is a topic we just covered a week ago on the Futurists. And then he also talked about future battles between robot armies, which sounded absurd at the time because robots were very scarce and very very rare, very expensive. It didn't seem like very likely. But now that also seems to be the case, right? So we know, for instance, that the Chinese military is investing heavily in drone aircraft and building ships that are capable of launching fleets of thousands of drones at once. So like swarm attacks. And the U.S. has to develop resistance to that, some way to defend against that. So it seems almost like the forces here, competitive forces between nations, are going to propel us in that direction. But it's admirable that you folks are choosing not to engage in that. And I know that that's been a lively topic at some other technology companies as well. How much should we support this, or how should we engage with it? Difficult call, because of course the militaries of each country need that kind of support if they want to advance.
And they're big buyers of tech, like robots.
That's right. That's right.
Yeah.
Okay,
so the deepfake topic is also interesting. I forced my family into an exercise over the holidays because I think that we're pretty close to a point where I might get a call from my daughter and she's in distress and it sounds like her, and she asked me to help her out by wiring her money. And I think it will become increasingly difficult to actually be able to tell if you're talking to one of your loved ones or you're talking to an AI that's impersonating her.
We had a great demonstration of that on our last show. It just blew us away, actually, with a deep fake expert. So Carl
Bogan came on the show, and he did the first half of the show with the deep fake, and then halfway through the show, he said, "By the way, this is not my face," and revealed his real face.
Yeah, it was
uncanny. He said, "Look, this is the year where you're going to be on a Zoom call and you will no longer be certain if the person you're talking to is really who they say they are, or even if they're a human being. It could be a machine pretending to be human." So that's a kind of like the future is coming really, really fast.
So I have
tell us a little bit more about
on that, because family passwords, of course, would be one way to get around this, right? That you have a family code word or family password. Problem is nobody can ever remember passwords.
So, humans are the weakest link.
Yeah, we're the weakest link. So here's an idea that I implemented. Get yourselves a box of Legos, for example, and build something together, abstract and absurd, out of the Legos. And that becomes your family password. Hey, do you remember what did we build together out of Legos on December 24th, right? As opposed to picking a password like yellow.
Right.
Great. Okay. A little tip for those who are listening, in case you think your children are no longer the people they claim to be on the Zoom calls.
build them in Lego. No,
Mark, give us a sense of where things are heading. So clearly there's an acceleration happening in robotics, but then more broadly in machine learning and artificial intelligence across the board. And that's going to drive different applications. As you mentioned, the form factors are going to evolve basically to suit different use cases. And we talked a bit about drones, right? So drones, you don't necessarily have to have legs or feet if you're building robots. You can have them flying and you can have them swimming in the water and so forth. So locomotion, as you mentioned, has been solved. What does this look like in 5 years or 10 years? Brett said that there should be more robots than people. I think that makes intuitive sense to most people. But today, the population of robots is only estimated to be somewhere between 3 and 5 million, which is a lot fewer than you would expect. Do you think we're going to have billions of robots in the near future?
I think they will. I'm sure we will. So I'm an optimist. I believe that things will work out just fine, and I do think that all of us will have multiple robots in our house with when this decade comes to an end. Many people already have vacuum cleaner robots or lawn mowing robots, right?
Yeah, yeah.
And you, so my washing machine, to some extent, is of course a robot without wheels. But now you come to this dawn of mobile robots walking into our daily lives. First in universities, then at work, but ultimately, in the next couple of years, into our homes. And I think it will be exciting.
We already have them here in Los Angeles. There are robots delivering groceries, and I see these robots on the sidewalks all the time. I live up in the hills where they can't quite get up the hill yet.
Yeah.
But down on the flat streets, you see them on the sidewalks, and they're really quite cute. They're very polite. If there are people, they stop, they pull over to the side, and they wait. They blink at you. They have kind of like humanoid faces on them with their lights. So it's interesting to see how they're making robots friendly. And I gather that's really valued in Asia. That is something that in Japan in particular, but I gather other parts of Asia where friendly humanoid robots are something people are being accustomed to and they actually like.
Yeah. This is a great thing to explore, actually, because Japan has spent, you could argue, the last 40 years preparing their society for the injection of robotics. But in a lot of the West, we have these fears about whether it's going to be safe and so forth. So culturally speaking, is there a cultural effect, do you think, Mark, in terms of broader adoption of robotics in society, that maybe China and Japan may have an advantage from their citizens in terms of acceptance of this technology, whereas versus in the West, we may have a bit more work to do to make sure that people know they're safe?
I think that's true. Certainly for hospitality and entertainment robots, right? The fictional narrative in the West is just too dark, and so I do think there will be more pull in the market for hospitality robots. But at the same time, here in the United States, if I go into logistics warehouse where I spend a lot of my time these days, none of the logistics managers that I talk to can find humans anymore to do these jobs. Right? Nobody wants to work in a container that is hot in the summer, cold in the winter, has no windows, and you literally have back-breaking work. Nobody wants to do that job anymore. And companies like Amazon and others have 120% turnover, right, for these jobs. You hire 10 people on a Saturday or Sunday, and on Monday only 3 of them show up. Right? So, I think the acceptance of mobile autonomous robots, will be very strong in Western countries for industrial mobile robots. But I think the pull for hospitality robots will be stronger in Asia.
No doubt there's a demographic driver here as well, because throughout the Northern Hemisphere now, populations are no longer reproducing at replacement rate. Even in the United States, if we did not have, if we didn't have immigration here in the U.S., we would not be at replacement rate. But that's certainly true in China and Korea and Japan. It has been for some time, but it's also true in most of Europe and Russia, that those populations are bound to decline. Yet there are going to be more old people and fewer young people, meaning not only will it be difficult to find people to do the hard work inside of, let's say, a warehouse, as you described, or in a mine, in a coal mine or something. It's going to be hard to find people to do work in a grocery store, to lift boxes there as well. So eventually there won't be enough young people to take on those demanding physical labor jobs. And that'll create the opening for broad acceptance of robots. That seems to me to be clear in the next 10 years.
Japan has this neologism they call the 3Ds. I don't know where they apply to robots. I don't know if you've heard it, but any job that's dirty, dangerous, or demeaning will be those that robots first attack.
Yeah, that makes sense. Exactly. We hear about robots being used for public safety, for firefighting, for, like you said, demining, like removing dangerous things. I know that most police forces have robots. I think that's actually where they use the Spot robot. The bomb squad will send a robot in to defuse a bomb, which is actually kind of amazing, right? You have to think that's a fairly intricate task. So that shows you a little the sophistication and the dexterity that's already ready.
Well, I think, Rob, they don't really diffuse it the way that James Bond does, right? By pulling the red cable and the green cable. Yeah. Really, what they often do is the robot is used to first confirm that there is a dangerous bomb in the bag that was found in the airport, for example. But then in the second step, they usually explode the bomb, right?
So the robot blows up.
Yeah, they do controlled explosion.
I see.
Yeah.
And as I recall, in the Fukushima nuclear power plant accident that occurred before the pandemic, the Japanese authorities also sent robots into that plant because it simply was not possible for humans to go in there in a safe way.
Yeah, we have robots today in all the nuclear disaster sites around the world. And what's interesting is that it opens up a whole new way to see the surroundings, because we have environments where we've sent robots where a human hasn't been in that room for 30 years because it's so contaminated. So we're working now on technology where a human can put a VR headset on and drive the robot in a room. And then it's almost like telepresence, right? And if you imagine that the form factor of the robot matches that of the human, so the morphology is the same, meaning you have a humanoid robot in the dangerous environment and you have a human with the VR headset on and gloves, it's almost like teleportation, right?
Yeah.
You could be in the confines of your home and you can teleport onto an oil platform in the Gulf and repair something, right?
That's astounding. So for humans, it's like virtual presence or extended presence. Maybe we're going to start to blur the boundaries between humans and robots. Brett, what do you think?
I mean, at this part of the show, because we're going to wrap up shortly, Mark, and I know you've got a hard stop on the air as well, but I want you to sort of put your futurist hat on. And, you talk about your dream for this. You've mentioned that sort of terminology a few times throughout this, your vision for the role robots will have to play. But let's say we're in 2050, or later. How is the world going to look with humans and robots working side by side?
I hope that by that point we've put robots to work in the most dangerous tasks, so that we get humans out of harm's way in dangerous environments. And I think we will definitely be able to do that. I also think that with the advances in AI, it is now possible to have an entertaining conversation with a computer. Now, I think that we are in a very good position to build magical hardware to catch that AI revolution and build a companion robot that will be fun and entertaining and lovable. Because all around the world, especially in the mega metropolis cities in Asia, there's a lot of lonely people, right? And yeah, buying a pet would be the better choice, but in many of those apartment buildings, you cannot buy a pet, right?
Yeah.
Or you may be too old to even care for a pet. But if you had a lovable companion robot that would live with you, maybe it helps with some chores around the house, but maybe it's also just there for you so that you have a companion in your life. I think that's certainly where I want to steer us and my career in. So I believe that will become a reality.
So one area I'm interested in, that we've sort of talked about these bigger robots, grocery delivering robots, humanoids, robots you sit in and so forth. But there's also, as you've talked about in the sort of form factor issues, as robots could be cleaning tanks and so forth. But what about miniaturization of robots? Mm-hmm. Like, we do have drones now with semi-autonomous drones that can be quite small. But if you've watched Star Wars, you'll see a lot of the droids are very small robots, and there's been that view of robots that can clean and do maintenance and things like that. But what about the concept of, you talked about soft tissue robots and things like that, but what about swarms of robots that can work collectively together and things like that? Is there going to be some benefit in more cooperative systems where these robots can do singular tasks and then, in groups as well?
Yeah, so two questions in there, Brett, right? So on the swarm factor, our next generation of our software that comes out in January, that is already software that can handle multiple of our robots at the same time. And you could envision a world where one robot holds open the door for a second robot, or they work together on lifting something that is too heavy for one robot. So I do see strong industrial applications for multi-robot coordination, which gets me excited. But in the miniaturization, I think the limiting factors currently are probably computing power, heat dispersion of that computing power, and actuators. We've made amazing advances in our actuators that we build in-house. And so I think we can now build very strong robots with fairly small actuators. So I do think that our robots will become smaller, more compact, therefore also safer. And that might lead the path towards a B2C robot. But
one of the things we've noticed now with artificial intelligence is the emerging capability for AI to write software. And that leads us to speculate that the next generation of software will be written by the software itself. Do you think that might also apply to robots? Will there be a time in the future where robots design better robots, basically design upgrades or better versions of themselves?
Yeah, that seems in the 50-year time horizon inevitable.
Yeah.
Okay, that triggers a whole lot of thoughts, sometimes really positive and some really scary ideas there. I guess I don't know why we're so ingrained.
Well, it's like the 3D printer that you can use to print a 3D printer, right? But we are talking about nanoscale, molecular, 3D printing machines and this sort of stuff that's also going to be possible in that time frame. So,
micro machines.
Very, very interesting to sort of think about.
So another way to look at it, apart from being afraid, is to think of it as an extension of human capabilities. Ultimately, that's what every technology and tool is a human capability is just extended or amplified. And what I think is most interesting about what you just shared, Marc, is this notion that through machine vision and network connectivity, we can see through the eyes of a robot. So that's basically an extension of human capability or extending our presence, right, to another place. This is a fascinating idea, and it is like VR. So with the advent of things like Apple's Vision Pro this year, we're going to start to see very powerful headgear that allows people to vividly embody or imagine what it's like to embody a different existence. The robot seems like a logical extension of that. In a way, it might be kind of fun. You can certainly imagine new kinds of sports or new kinds of races that will happen, robot races and so forth.
Yeah, robot Olympics, right?
My goodness gracious, what a world we're moving into. Well, that's the other thing, actually. We didn't talk about prosthetics, but that's where actually the MIT lab that spun out Boston Dynamics in the first place was the LEG lab, right? You were it was a prosthetics laboratory. And so the idea of restoring mobility.
Wasn't Dr. Hugh Howey involved in that stuff?
That's Media Lab, different group.
Oh, okay. Right.
But the notion there is that this can restore capability to humans who've lost it, and I think that's another very powerful idea. What do you think of Ray Kurzweil's vision? He wants to try to recreate his father from his memories of his father. I mean, this sounds a little fanciful or maybe a little sentimental sometimes when he talks about it. But the notion there is that we have enough residual memory of people who are no longer with us that we might have the ability to recreate them. You can certainly imagine in terms of like the robot companion that you were talking about, someone might wish to do that someday in the future and, kind of create a version of someone that they loved who's no longer with them that they can have around. That sounds sad.
Or for us to leave a copy of ourselves for our kids
to take care of.
I think there's one of the big artist agencies is already offering that as a service, right? That you go in and they scan your entire body, they scan your voice, and if you ever die or you don't want to go on location, they can now use that digital twin to put into movie, like they put Princess Leia in one of the last Star Wars movies, right? So from a technology perspective, we're already there that you could create a digital version of me that sounds like me. It's maybe not as funny as I am, but certainly looks and sounds like
That's me. What you say. Yeah.
Yeah, it might be funnier, right?
No, that's cool. So, Marc, we are running out a bit of time, but it's been a fascinating conversation. What are you hoping for Boston Dynamics over the next couple of years?
Well, I think right now we're in the midst of trying to build a commercial engine, right? And going from building amazing magical research robots to building repeatable, standardized, highly reliable industrial robots that are still magical, but that do real work in factories that provide amazing value to our clients.
And you guys do very well with the whole PR cycle and so forth. We've been learning about Boston Dynamic robots for many, many years now. But where can people stay in touch with what you're doing at Boston Dynamics and sort of learn what's coming down the roadmap?
Yeah, so we have a very popular YouTube channel, which I would recommend people subscribe to. We're now on, we have a funny channel on TikTok, which is a little bit more lighthearted. And then, of course, our website, bostondynamics.com, has all the latest and greatest if you are more of an industrial client of ours.
Well, fantastic.
Great.
Well, it's been wonderful to have you on the show.
Yeah.
And it's really insightful to see. It's also great to see someone who is helming a company like this to really show you've thought about a lot of these broader issues, which I find really a healthy basis for us moving forward. Rob, do you want to wrap us?
Sure thing. Well, Marc, it's been a great pleasure to have you here. Marc Theermann, the Chief Strategy Officer at Boston Dynamics. Thanks for joining the Futurists this week. And a big shout out to our crew at Provoke Media, Kevin Hirschhorn, our engineer, Elizabeth Severance, our producer, and the rest of the crew at Provoke that make the show possible. And again, as always, I want to thank our fans and listeners. Your support is great. It's what makes the show happen. We're thrilled to do it for you each week. And every week, we'll come back to you with another Futurists. Until then, well, I guess we'll see you in the future.
In the future.
Thank you.
Thanks. Well, that's it for the Futurists this week. If you like the show, we sure hope you did. Please subscribe and share it with the people in your community. And don't forget to leave us a 5-star review. That really helps other people find the show. And you can ping us anytime on Instagram and Twitter at Futurist Podcast for the folks that you'd like to see on the show or the questions that you'd like us to ask. Thanks for joining. And as always, we'll see you in the future.